In this podcast, I want to show you how to plot lines of maximum and minimum slope using Excel, and to do that I've decided to use the data that we collected on the other day when we were doing the G using 3 methods experiment. So this is the photograph of the ball bearing falling against the ruler with a strobe light flashing against it. And I've inverted the image so that we're now looking at a negative. We see the dark spots are the positions of the ball falling, and I want to use that data to determine the acceleration of gravity. So I want to find the position of the lines. I want to find the position of the lines, and I'm going to do that very quickly using Photoshop here. I'm going to draw lines against each of the dots using a straight line tool, and then I'm going to record the data and transfer it into Excel. So I've drawn the lines for the positions, and I can see that there's definitely a bit of uncertainty there, possibly an uncertainty of plus or minus 1 millimeter, maybe even more due to the size of the spot, but I think maybe plus or minus 1 millimeter is going to be okay. So I'm now going to take that data, I'm going to transfer it across into Excel. So I have time in my first cell there, time in seconds, and the next one is going to be the position as recorded from the ruler. I'm going to record that in centimeters. Those are the first 2 bits of data that I want to fill in. The first dot will represent a time of 0, and each subsequent dot flashed 0.01 seconds, hundredth of a second later. So I can fill in the rest of this here. I think I've got 10 dots, something like that. So those are the times there. I'm going to make sure that they all have the same number of significant digits. I'm going to increase them by 1. There we go. So we have 0.00 all the way up there, that's fine. And the position, I'm going to read the position off the photograph. So the first position is 3.7 centimeters, followed by 4.8, 3.7, 4.8, and there's the rest of the data there, which I've just transferred across. Again, I want to make sure that I've got uniform significant figures or decimals here. That's too many really, because I only read to the nearest millimeter, so that's fine. The next column I want is the change in position. The change in position. So let's call it the change in position. Again, measured in centimeters. So that's overlapped the cell there. I want to wrap text, which will put that down a little, maybe even expand the box slightly. So change in position. So the first one, we don't have a change in position for that one, but the next one, it's the initial position minus the current position. So I can get Excel to do that calculation for me. I'm going to hit equals, tells Excel that a calculation is coming, and it is this one, so I'm going to click it, minus this one. Click that one, enter. I have a number. Now I'm going to just fill down and it will do the rest for me. There it is, all done. The next column is going to be the velocity of the marble during that hundredth of a second. And that's going to be calculated by taking the change in position and dividing it by 100th of a second. So this is velocity measured in meters per second. Now I want to superscript that bit there, to the -1, so I'm going to highlight that, and I'm going to go to the Format, Cells, drop down, and you can see superscript, check superscript, and there we have what we want to see there. I'm going to wrap that text. Actually, that's not looking so good. I'm just going to stretch the box out there. So the velocity is the contents of this cell divided by 0.01. So we're going to put equals in this number divided by 0.01, enter that, and that's the velocity in centimeters per second. I need to change that heading. Click and drag down, go back up here, put a C in there, centimeters per second. So that's the velocity in centimeters per second. Now let's consider the uncertainty. The uncertainty in the position was, I suggested, 1 millimeter, plus or minus 1 millimeter, which means the uncertainty in the change in position, which is one of these numbers minus another number, is going to be double that amount. So the uncertainty in position is plus or minus 0.1 centimeter or 1 millimeter, and here it's going to be plus or minus 0.2 centimeters. So let's put that in. So I need to say Shift Alt J. Oops, Alt J, not Shift Alt J. Alt J, which gives me the delta sign. So uncertainty in position, let's call position D, is plus or minus. That's Shift Alt plus, plus or minus 0.1 centimeters. That needs to be wrapped. And the change in position, I'm going to do the same thing. So we have Alt J, Shift Alt plus 0.02 because I've 0.2 centimeters because I've doubled the uncertainty, subtracting one thing from another, and that's that. The uncertainty in time is going to be based on, well, I guess the limit of reading of the strobe, which we don't really know. I'm actually going to ignore that. I'm going to assume it's very small compared to the uncertainties here. So we need to work out the uncertainty in the velocity now. So the uncertainty in the change in position, 0.2, we're going to have a look at that as a percentage. We're going to consider what it is as a percentage. So the uncertainty as a percentage, 0.2 in 2, hopefully we can see that that's an uncertainty of 10%. 0.2 divided by 2 times 100 gives us 10%. Looking down here, 0.2 divided by 1 multiplied by 100 is going to be around 20%. So to keep things simple, I'm going to say that my uncertainty in the velocity is somewhere between 10 and 20%, let's say 15%. So Alt J, I'm going to have to unsuperscript that in a minute. Shift Alt plus or minus, now that's a percentage uncertainty, so I need to put a percentage in there. Percentage uncertainty plus or minus 15. Let's go and unsuperscript that, and there we have it. So plus or minus 15%. So let's graph this data, see what the graph looks like. Charts, and we want a scatter, marked scatter. Now I'm going to control click on that area just so I can select my data. I'm going to add a series. I'm going to call it velocity versus time for ball. My x values, so my x values are going to be time, and because I only have values of velocity from this point onwards, I'm going to just select those data points there, and my y values are going to be here. They're slightly hidden under the graph there, and that looks pretty good. Okay, so you can see there's a lot of random scatter in that. I'm going to put the axes in. I'm going to go up here to chart layout and axis titles, horizontal. This is the time in seconds, and I'm going to do the vertical one, and this is velocity in meters per second. ms-1, I'll format that in a minute. And we want to add a trend line to that, so I'm going to control click on any data point to add the trend line, and we're expecting it to be linear. There's the linear trend line, and I'm going to also click options so I can display the equation on the chart. So there we are, there's my equation. Just pop that down there for the time being.